discussed about drum brakes. You can go through this video. See, the working of drum brakes we had discussed in the class. Same mechanism is shown with the help of this video, right? So whenever you apply the brake, okay, through the adjuster, okay, so that this will move away from each other. So this will move down, so that the force will be applied. You can see the F here, so that they move against each other. Okay, both the shoes, so that the liners will press the drum, so that the brake will be applied. After certain period of time, say 10,000 kilometers or so, these liners will be worn out. They are usually made of metal. They will be removed and replaced by fresh liners. Okay, so this is the concept of drum brake we had discussed in the last class. Disc brake we had completed in the last class. I had given you the example of a motorcycle also. Then swinging caliper disc brake. I think I have a video. This also we had completed in the last class.
Yes, sir.
Just let me show you this, because I shortlisted a video for better understanding. Once again, please. Swinging caliper disc brake. Can you see the disc brake working now?
Yes, sir. It's visible.
There is an animation. I have downloaded an animation, so it will be easy for you to understand. Okay, this also we have completed in the last class. How a disc brake works. So whenever you push the pedal over here, you can see the pedal. Okay, whenever it is pushed, so you can see here there is a disc. This disc will be connected to the wheel. So there will be a caliper, okay, inside which two discs will be attached. So because of the fluid pressure, okay, this both the discs will this both the calipers will jam the disc whatever is there. So this disc will be connected to the rotor, so that there will be an immediate application of brake. Is it clear? So if I show you the animations and videos like this, it will be easy for you to understand. Okay, then this floating caliper. Is the screen visible?
Yes, sir.
Sir, yes,
Floating caliper brake. See, it clearly explains you how it works. This is an example for hydraulic system again. Same disc brake, how it is working. When you apply the brake, the fluid pushes. One end is fixed, other end is movable. This end is fixed and the other end can move. Okay, so the next type, I think we were at this point, sliding caliper type, correct?
Yes, sir.
Please make a note of it. Take down a rough sketch.
Sir, sir.
Yes. Now, why it is called as sliding caliper type? So this region is the caliper. Whatever you can see, this is the caliper. Okay. So there are two pistons. Here you can see this is piston number 1 and this is piston number 2. Okay. So these are the brake pads. Whatever you can see here, these are the brake pads and this is the disc. This is the disc. Is it clear? So first we have discussed about various parts, right? So caliper, this is the caliper.
Yes,
Two
sir.
pistons are there, 1 and 2. Okay. Two friction pads or brake pads are there, 1 and 2. And this is the disc. Okay. To this disc, the wheel will be directly attached or the rotor will be directly attached. When you apply the brake, okay, so the high pressure fluid enter into the cylinder through the hose. Okay. So when it comes here, what happens? The piston P1 will be moved in this direction and piston P2 in this direction. Is it correct? When the cylinder is pushed, I mean, when the cylinder is filled, pressurized with the fluid, both the pistons move away from each other. Is it correct?
Yes, sir.
Okay. Now, what does the piston P1 do? When it moves backward, it will press this disc. Is it correct? Okay. Now, piston 2 also moves backward, so that this caliper also moves in this direction. You can see here clearly, the caliper is directly attached. So this is the caliper or the casing. In simple words, I will call it as casing. The casing is directly attached to piston P2. Whenever pressure is increased, this casing also moves in the reverse direction. So that you can see here, brake pad A and B are there. So this brake pad moves in the forward direction, whereas the second brake pad moves in the reverse direction. So both of them press this disc so that the brake will be applied. Okay. The name sliding caliper is given because the caliper slides. Okay. The caliper slides in forward direction whenever you apply the brake. Hence the name sliding caliper type is given. Any doubts in this, you can ask me. It's a very simple thing. If you try to understand, it will be much easier.
Yes, sir. No doubt, sir.
Good.
Okay.
I have taken these sketches from the prescribed textbooks only, so that it will be easy for you to draw in the exam also. I have not referred any animations, complicated sketches. The most possible simpler ones from different books I have chosen and I have taken.
Okay, sir.
Okay. So we have studied about the types of brakes and design consideration and classification of brakes so far. The next, the most important component which comes in direct contact with the wheel is the brake pad. So the next concept is, what are the different materials that can be used for manufacturing a brake pad? The first one is, you can use certain non-metals. Okay, they are made up of combination of various synthetic substances like composite materials, okay, cellulose, okay, aramid, etc., and sintered glass. Okay, they are gentle on rotors but produce a fair amount of dust. Why dust? Whenever you see any composite material in our labs, some students are doing projects, you can see the artificially fabricated components, okay, brake pads. So whenever you apply the brake, they wear out at a faster rate. Okay, so that when they wear out, they come out in the form of a powder. The cellulose, it may be polyacrylic nitrate, PAN or aramid, they form a powder when heavy friction is applied. So usually these similar type of materials you can use as non-metals in the brake pads. The next class is semi-metallic. Okay, synthesized means it is not available naturally. You have mixed 2-3 components to produce a new component. Okay, so even non-metallic also we use the word synthetic substances. So the next is semi-metallic. Okay, so it is synthetic material mixed with varying proportions of flaked metals. Okay, in the form of flakes, okay, or sheets. Different metals are taken. Okay, and they are joined together to form a brake pad. They are usually harder than non-metallic. Okay, they fade resistance, fade in the sense wear and tear. Okay, they can last longer. Okay, cost will be obviously more. Why? Because whenever you think of metals, certain metals are very costlier. Okay, so that it will be cost will be more. Also, they will be little bit heavier when you use material. It will not as lighter as that of composite material. So you need to apply more amount of force. Okay. So the first class of material is non-metallic. Second class of material is semi-metallic. The third is fully metals. Okay, these pads are used only in racing vehicles and are composed of sintered steel. Okay, steel with certain synthetic additives to give it more friction resistance and heat resistance. Okay, they are long lasting. Okay, they require more amount of force to be applied. Okay, they also tend to be very loud. They give a lot of noise when braking is applied. So they will be definitely very much costlier. Okay, sintered steel with certain synthetic additives, they will be definitely costlier. Only in very high speed cars like racing cars it will be used. Okay, so the last class is the ceramic. Ceramic is usually made up of clay and porcelain. Okay, and certain amount of copper flakes are added. Okay. Why copper flakes? Again, they are good conductors of heat. They remove heat at a faster rate. and to some extent they give fade resistance. So copper flakes along with clay and porcelain are added. Okay. These are good compromise between durability of metal pads, grip and fade resistance. Okay. So their principal drawback is that despite the presence of copper, ceramic pads generally do not dissipate heat very well. Okay, which can eventually cause the pads or the components of braking system to warp. Warp means because of heavier heat. Okay, they deteriorate over a period of time. Okay, so ceramic material causes the braking sound to be elevated beyond that of human hearing. So they are exceptionally quiet. So usually ceramics are preferred. Okay, so these are the different materials that can be used. Only naturally available fully metallic materials are used in racing cars. They are much costlier. Either semi-metallic, non or usually ceramic material are used as brake pads. So this is regarding the different materials used in brake pads. You can take down. Okay. So far we have discussed two types of braking system, disc brake and drum brake. Now we will just study the difference between disc and drum brakes. So disc brakes, okay, in disc brakes usually flat friction pads are used, wear is more uniform. So you'll have a uniform wear and tear, whereas drum brakes, semicircular friction pads are used. You have notified, I mean, you have seen that. Once again, I'll go back and show it to you. Here, whatever friction pads we are using or brake pads are not flat. They are semicircular in nature. These two are the brake pads, okay, as we discussed. Whereas here, these are the brake pads in case of disc brakes. In disc brakes, it is flat. So whenever the force is applied, whatever wear and tear is there, across the pad, it will be uniform. Whereas if you consider the drum brake, okay, so whenever brake is applied, the wear and tear will not be uniform. Depending on the situation, sometimes only the top portion may wear out or bottom. It will not be uniform usually. So that is the first and foremost difference. Okay, disc brakes have more efficient cooling compared to drum brakes. Okay, disc brakes are stable. As you know, I gave you the example of a two-wheeler also. Disc brakes are more stable and you can rely on it at any speed. You can control the vehicle. Okay, maintenance of disc brakes is very easy as compared to that of the drum brakes. Okay, drum brakes requires a lot of components to be dismantled for maintenance. Okay, usually disc has good anti-fade characteristics compared to drum brake. Okay, the disc brakes do not have servo action and decrease the braking force required. Okay, this servo action we will be discussing in the upcoming slides. In general, we can conclude like this: disc brakes requires lesser amount of effort for braking, whereas drum brakes require more amount of efforts for applying the brake. Okay, total friction area available in disc brake is less as compared to drum brake. Obviously, when you consider a straight flat material and a semicircular, area of contact in semicircular will be more. When area of contact is more, obviously more amount of wear and tear will be there. So these are some of the differences between disc and drum brakes. Please make a note of it.